We are live. Okay, here we go. Today's date is Diciembre 9. Noviembre. 10 noviembre. Noviembre 2021. See? So today what we're talking about is geometric sequences. And a sequence is just a list of numbers, okay? So a sequence is a list of numbers in order. In order, okay? So I'm going to highlight that word, in order, okay? We looked at arithmetic sequences, oh gosh, a good month ago. And we didn't spend much time on it because we were running out of time, but I'm going to put down that here in a second, but it's just a list, but the numbers have to be in some kind of order, okay? About a month ago we talked about arithmetic sequences. And an example of that would be, say, 1, 6, 11, 16, 21, ... That's arithmetic. Arithmetic because we are adding, can you see it? Plus 5, plus 5, plus 5, plus 5, plus 5. That's what this makes this one arithmetic, okay? And a month ago, we said that you find what we call the difference between each term. And so we'd say our difference in this case is 5. And we had a formula. We had a formula for that. And you don't have to know the formula, but I'm going to put it up there anyway. So for the arithmetic, the formula is a of n equals a1 plus n minus 1 times d, okay? So that's not this lesson. We're not doing that today, but we're going to do the geometric ones instead. Okay, so this is what we learned a month ago. Arithmetic, easy. This was arithmetic because you add, or you could subtract, but it always has to be the same. That what? Yeah, that's going to be geometric. Yeah, no, you're right. So, like Benny said, what if you multiply? So if you multiply, it's geometric. As long as you multiply by the same thing, right? So what we have is a geometric sequence. So geometric sequence is a list of numbers that are multiplied, right? Multiplied by some, we're going to call it ratio, okay? Some ratio, okay? We're going to call it ratio for R. The reason they call it a ratio is because you can multiply by a fraction. I mean, a ratio is a number like a fraction, so you could multiply something by, 2/3, and 2/3, and 2/3, and 2/3, right? So obviously in this case we're multiplying by what? And 2 can be a fraction, 2 over 1, right? So it's still a ratio. So I agree, our ratio is 2, right? So in example 1, it is geometric, definitely geometric, because our ratio is 2, and we're multiplying, okay? Thumbs up. Can you see that? Just times by 2, times by 2, times by 2. It is geometric because we're multiplying by the same number. So what's our next 3 terms? What's our next 3 terms? Okay, I think it's 48, then what? 96, and then what? 192, okay? Now if I want to graph this sequence, I'm going to get a piece of graph paper out. Let's see what it looks like. Give me a second. Get some graph paper. Let's see if I can graph this. Alright. Get my graph paper out. All right. And I'm going to put down my x and my axis. All right. Okay. I'm just going to go to 24. So to get up to 24, I'll probably go 2, 4, 6, 8, 10. Maybe I'll go 10 here. 10, 20, 30, 40. Okay, you got that? So we did this a long time ago, but we're going to call that the first term, right? So we use the symbol A1, A2, that's our second term, A3, A4. Okay, so let me write that down. They use the symbol A1 for your first term. It's just math symbol, so we know that A1 is 3, A2 is 6, A3 is 12, A4 is 24. And I can do A5 because I have room for A5 on my graph. And A5 will be 48. Okay, so now when I put this, I'm going to go A1, A2, A3, A4, A5. Now if you forget to put down the A's, I will not count it wrong, but it really represents the first term, the second term, the third term, and the fourth term. Okay, so I'm going to graph those. So I'm going to go ahead and go A1, which is 3, which is about, I'm going to guesstimate 3 to be about there. 6, 12, 24, just guesstimating, and 48. 48, okay. Okay, what does it look like? We've seen this graph. In fact, we just did a concurrent. What does it look like? What's the word? It does look like exponential, doesn't it? It is. It is exponential, okay? So, if we want a formula for this, we're going to take a look at our formula. It's going to be y, write this down, a of n equals a1 r to the n minus 1 power. Okay, I want you to write that down, okay? Write that formula down, okay? It's pretty similar to our y equals ab to dx, isn't it? The formula looks pretty similar to what we had. We had this y equals ab to dx. It's very similar, isn't it? Very similar. I mean, these two formulas look almost the same. There's one thing, though, this one does not have. Okay, this is super easy. There's the first term. Look at it. It's 3. There's a second term. There's a third term. There's a fourth term. There's no such thing as a 0 term. There's no such thing. I got a term. I got one term. I mean, that's my first term. There's no such thing as a 0 term. So there's no dot here. And don't connect dots. Do not connect the dots. Do not do this. Because there's no 1.5 term, is there? There's no 2.5 term. There's either a term or not a term. There's no such thing as that. Half a term? What's half a term? Doesn't make any sense, right? So when you do these sequences, it's just this number, this number, this number, this number. Don't connect the dots and don't make a 0 term. And so that's why it has an n minus 1, because there's no 0 term. Okay, now, making the formula is easy. If you have this, if you have the general form, then my formula is going to be a of n equals a1. What's my first term?
3.
What's my multiplier? What's my r? To the n minus 1 power. That's the formula for that geometric graph. That's it. Okay, let's look at example 2. Okay. 64, negative 16, 4, negative 1. Is this geometric? Yes or no? Okay, say yes. I do. I think it is. So what do I see? I think it is. What do you see? What's going on? Anybody? Can anybody tell me what's going on? Yeah, Grace? Awesome. Awesome. Can I say what you said? You're totally correct. Can I say it like this? We're multiplying by 1/4 is the same. It's exactly what you said, isn't it? You said divide by negative 4. I'm going to multiply by negative 1/4. We're saying the same thing, aren't we? Good job, Grace. So my ratio is negative 1/4. If I graph this one, all right, hold on, let me get my graph paper out. Make a little graph of this one. Let's see what it looks like. I get my graph paper out. And nice job. I'm going to have to start way up at 64. Oh, I got to get the next 3 terms. Okay, what's my next term? Anybody know what my next term is? So I'm going to take negative 1 times a negative 1/4. Isn't that what Grace said? What's my next term?
1/4.
Good. And then? How about 16th? How about a negative 1/16? Where'd the negative come from? Yeah, positive times negative. And then what's my next term? What's my next term? What's my next term?
1/64.
Yes, 1/64, because we're multiplying by negative 1/4, multiply by negative 1/4, multiply by negative 1/4. Thanks, Michael. All right, so let me go ahead and I'm going to graph this. All right. So I'm going to go ahead and, I got to get all the way up to 64. Oh, actually, I made my graph wrong. I know I did, because I got to go positive, negative. Well, it might be okay if I go by tens. Oh, if I go 10, 20, 30, 40, 50, 60. I might be okay. Let's see. First term is 64, which is up here. Then negative 16. So I'm going to go down here. So I went way down there. Went there, then there. Wow, went up there, then down there. Then we go to 4, like there. We go to negative 1, which is about there. And then I'm going to go here. What's it getting closer and closer to?
The x-axis.
Which would be a y value of?
0.
Good. It does, and you can see it's getting closer and closer to 0. You guys agree? Okay, the equation, right? Equation. We're going to go, let's see, y equals, I'm sorry, a of n equals a1 r to the n minus 1. That's the formula I have to use. That's that one there. So a of n, what's my first term? What's my first term? a1, what's my first term? 64. You guys see that? First term, 64 times, what's my multiplier? Grace, what's my multiplier? Awesome, negative 1/4 to the n minus 1 power. Now, if I had to find the 10th term, I'm just going to plug in 10. Okay, I'm just going to plug in 10. So I'm going to go a of 10 equals, okay, a of 10. I'm looking for the 10th term. A of 10. A of 10 means, hey, what's the 10th term? A of 10 is equal to, well, 64 negative 1/4 to the 10 minus 1 power. Now I'm going to need a calculator, which of course I don't have. Of course I don't have a calculator because I can share mine with everybody, don't I?
Why do we use A?
Why do we use A? Great question.
Like, what does A mean?
A means a term. It's a symbol for first term. So then you're not, why not use T for term? But they use T for time. So they don't want to use T. Does that make sense, Mars?
Yeah.
You do always ask those questions. Okay? You do ask great questions, okay? So let's go ahead and I'm going to go in my calculator. I'm going to go 64 times a negative 1/4 to the power of 10 subtract 1, right? You guys see that in my calculator? It's going to be really small. I know it because it's getting closer and closer to 0, right? So I get about it. And I see this e. What's this e negative 4 mean? Well, I get this negative 2.4414e negative 4. It means take my decimal, and move it 1, 2, 3, 4. So my answer is a negative 0.0002414, okay? That's my e. E negative 4, right? E negative 4, my calculator's trying to say move that decimal 1. See this e negative 4? Move it 1, 2, 3, 4. Yes, Michael.
Why didn't they just move the decimal?
It depends on the calculator. Maybe your calculator does. It depends on your, if you have a better calculator, it'll probably automatically do it, right? Right? I might be able to turn it off. Let me go to my mode real quick.
Both calculators do it. I just did.
Let me go straight to, instead of floating decimal, let me go to decimal 5. No, it still did it. Okay, let me go back to mode. I can take it off scientific. Nope. All right, anyway, I could probably fix it. Okay, turn the page. All right. A, take a look at this. Is it arithmetic? Is it geometric, or is it none of the above? Is it arithmetic, geometric, or none of the above? What's going on? From 5 to 1, from 1 to negative 3, to negative 4. What's going on? What's happening? What are we doing?
I'm saying this one's geometric. Going down,
What you said is correct. What you said is correct, right? With you, Ron?
yeah,
So Ron said, what is it?
arithmetic.
Because we're going down by the same amount each time. So it has a difference. There's a difference of 4. So it goes subtract 4, subtract 4, subtract 4. Goes subtract 4, subtract 4, subtract 4, subtract 4. So it's arithmetic. Good job, Rowan.
For arithmetic, it doesn't always have to be. Oh, sorry, never mind. That's geometric.
Right. So what about B?
Geometric.
Yes. What are we doing? What's going on?
We're multiplying by. Wait, no, we're dividing by.
So you and your sister say it the same. You're dividing by 8, and I'm going to say multiplying by 1/8. Same thing, right? Same thing. Mars, you with me? Divide by 8, divide by 8, divide by 8, or multiply by 1/8, right? Since it's times, 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 it is geometric. You're right, Mars? Perfect, okay? Okay, why is it neither? You're totally correct. Why is it neither?
Because it's going +4, then +6.
Right, right. And that +6 messes me up. It's like, what? What? Good job. Okay. So graph the sequences above. All right, let's see if I can do this. I'm going to go 5 is my first term. 1, -3, -7. Okay. What kind of graph is that? What kind of graph is that? Ooh, it's linear because it's straight. You guys agree? Awesome, it's linear. It's also arithmetic. We knew that. So it's linear. So linear and arithmetic go together, right? All right, let me graph this one. I'm going to go, let's see, I got to go probably 1,000, 2,000. So that means that's 500. That's 250. So if I graph this one, I'm here. Then I'm here. And I'm here. And you can see it curves like our J. And we know that's going to be our exponential. So what we know is geometrics are also exponential. And this one, like Bailey said, all of a sudden you go plus 6. That just doesn't make any sense. So I can go 2. All right, and then I jump to 6, 2, 4, 6, then 10, 2, 4, 6, 8, 10, and then 16. That one messes me up. Okay, all right. All right, here comes the fun one. Given the first triangle, the next is formed by drawing a triangle inside. How many triangles are in the second and third? Well, okay, so first of all, there's one triangle here, right? How many triangles in the next one? 4, right? 1, 2, 3, 4. How many triangles in the next one? Let's count, okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, there's 16. So T3, I don't want to graph 3. I don't want to draw T3, but how many, or T4, I'm sorry. I don't want to draw, this would be like way too hard. So how many triangles will be inside of this one? Ooh, how'd you get that? You just multiply. So there's always going to be 4 triangles in every one, right? 64, awesome. How many triangles will be in the 10th one? Well, how about a formula? It's kind of like 1 times 4 to the n, isn't it? But it's n minus 1, so we have to use our formula, okay? So we have to use our formula, and if I wanted to find the 10th triangle, I'm just going to put 10 in right there, right? Because this is faster, much faster. All right, so I'm going to go, let's see, clear. I'm going to go 1 times 4 to the, how about 9th power, save myself a step. So the 10th one would have 262,144 triangles. I would hate to draw that. I'd hate to have to draw that. I would hate to have to figure that out. It'd be brutal, okay? All right, so what do you guys think? Thumbs up, not too bad? All right, so here's what we do for homework today. Page 181. 120 all. It's not hard. It sounds like a lot, but it's not hard. It's a pretty easy assignment, okay? Let's get it done so there's no homework over the weekend, right?